And let me do this integral by 4 methods. Method 1, I substitute root x by t. So x is equal to t squared. So my integral become arc sine t, right? So it is 1 minus t squared. And the dx will be 2t dt. Okay. Now next step, arc sine t. Now the remaining part I try to write this way. Now I don't have an equal sign yet, so I just make adjustment to maintain this equal sign. So what is this? D square root 1 minus t squared is equal to 1 minus t squared, right? Negative 2t dt. So this one is equal to negative t dt and the square root 1 minus t squared. I do have t. I do have a square root in the denominator. What I'm missing is negative. So I take a negative out and the 2 here, then it's equal. Okay. So next step will be u dv, so by parts. So uv, right? I write v first because it looks better. Arc sine t minus integral v du. My v is this. U is arc sine t. So this is equal to 1 minus t squared. And dt, right? Yeah. So the result will be minus 2 square root 1 minus t squared arc sine negative arc sine t plus, right, plus 2, this is cancelled out to become t plus c. So that is the result for the integral. Then I just convert t back to x. So this will be minus square root 1 minus x arc sine square root x plus 2 square root x plus c. So that is my very result for the original integral. Now method 2. Method 2 is very similar to the method 1. Instead of I mention what is t, I just simply don't show the substitution. So I write equal sign. I don't write equal sign yet. I write the derivative of square root 1 minus x. No equal sign. I just make adjustment to keep the equal sign back. Okay. So that one. Now this is equal to 1 minus x dx, negative, correct? Yeah. I don't have a half here, so I'll multiply by 2. Then I don't have negative here and put a negative there. Then they are equal. Equal negative 2, okay? then they are equal, okay? Because this equals this. Now is equal to negative 2. I can use it by parts, right? UV, U times V. So this is my V, this is my U. Minus V du, minus integral V. V is this. Du is arcsine derivative 1 minus, this is square, which is x. Because this is a square root x, that's a chain rule, right? You have the derivative of a square root. Now this is equal to minus 2, 1 minus x, arcsine inverse x. This is cancel out. D root x integral is a root x. So this becomes 2 root x. See, so that is the same result. But this method, I'm not showing the substitution. Okay, method 3. Method 3, arcsine inverse 1 minus x dx, right? Third method, I'm going to let t be this. T be the square root of 1 minus x. So x will be x equal to 1 minus t squared. So my integral will be arcsine square root 1 minus t squared over t, right? Dx is no room right here, okay, minus 2t dt. Okay, so far so good. Now, no equal sign yet. I just want to make adjustment to maintain that equal sign. Now t and t cancel out. So negative 2 is out. So this becomes is equal to negative 2 inverse arcsine inverse sine 1 minus t squared and dt. That's right. Must be very careful. Okay, now I'm going to use by parts again. This is my u, right? This is my dv. So this is equal to u times v, right? This is v. This is my u minus v du integral v is t, du is equal to square root 1 minus, this is square, right? This is square is 1 minus t square. Since this is a composite function, so we have to use chain rule. The chain rule is this. The square root derivative is 1 over 2. 1 over 2 square root multiplied by the derivative inside, which is a negative 2t dt. Okay, that is the step after by parts. So this one is equal to negative 2 t arcsine square root 1 minus t minus integral, one cancel out. T square root is t, so that t is cancelled. Well, let me. So this t cancel with that t, right? This is a t. So remaining is 2 to cancel out. Remaining is t over square root 1 minus t square. Negative will become plus. Yeah, dt. Okay. Then this one is equal to negative 2t arc sine 1 minus t square. Negative 2. Bring negative 2, right, is negative. Now this integral, I'm using 1 minus t square negative half, right? dt, is the derivative of 1 minus t square. This will be negative. Negative become positive, right? Here, yeah. And 2, you have a negative 2t. I don't have 2, so I divide by 2 again. Well, so far so good. So this is equal to negative 2t arc sine 1 minus t square plus this plus 1, right? This becomes 1 plus t square. No, 1 minus t square half 1 over half. Yeah, that's it. The power rule for integrations. Then this one is equal to negative 2t arc sine 1 minus t square plus 2 1 minus t square plus c. And finally we put the assumption, substitution, convert back for x. So this t is square root of that one minus 2 square root 1 minus x arc sine. This is arc sine square root of x plus this is square root x. So it's, yeah, we get the same answer, right? Okay, this is method 3. Now method 4. Method 4 is this way. Okay, minus arc sine. Method 1, we use substitution for square root x. Method 2, we use we don't show the substitution. Method 3, we substitute this square, right? So method 4 is let arc sine be t. Okay, let t be my arc sine square root x. So substitution, we just bring new variable, try to solve the problem. Then square root x is sine t. Okay. Then x is equal to sine square t, right? So my new integral, this will be t. Yeah. This will be this will be 1 minus sine squared t, right? Yeah. dx will be 2 sine t cosine t dt. Okay. Now this is the cosine, right? Cosine cancel out. So 2 is out. Yeah, 2 is out. Integral and t and sine t dt. Yeah. This kind of integral is not difficult. We simplify parts, right? So this one is equal to t d cosine t. Cosine t derivative is negative sign, so I have a negative outside. See? Negative 2, huh? Now the reason of doing this way is that simply we are bringing the method of by parts. So 2, this is a u, this is a dv, okay, uv, right? Yeah, t times cosine t minus integral v du. This is v, right? This is v. This is du dt. So this integral is very easy. It's equal to negative t cosine t plus 2 sine t, right? Let's see. Now then we have to convert that for x. We draw a triangle. Sine t is root x. So this is a t. This is a root x. This is a 1. Right? So this is a 1 minus x. Now for cosine t is this, right? T is arcsine root x. So this is a negative 2 square root 1 minus x arcsine root x. That is t. Sine t is root x. So plus 2 root x plus c. So that is the same result as we did by the other 3 methods. So altogether I have 4 methods. Now this integral is not difficult to do, but it's a very good example to practice the basic techniques of integration, you know. So this is very good question for those who take the basic calculus course. Very nice to practice all the basic techniques, substitution by parts and so on. Thank you for your watching.